So this is session 6. We're going to talk about exam 2. Turn off my camera. Helps with bandwidth. Exam 2, sections 13 and 14. The good news is, for the most part, 13 and 14 are really easy. And I'm going to kind of focus on the hard parts to help you get. So it might seem a little confusing because I'm going to go over the harder parts, but it's actually a much easier section, I think. Okay, so what's going to be due? Well, the test review and the exam 2 are due Sunday, but I have office hours 8 a.m. I'm sorry, 8 p.m. I could have them at 8 a.m. if you wanted, but most people don't. So Sunday, 8 p.m. office hours. If you want to ask me any questions before you take your exam, you're more than welcome to. We can go over problems, anything you want. That's fine with me. But Tuesday, sections 13, 14, and discussion 6 are due, okay? And I would be willing to extend the homework if you know, in your case, if you need this 13 and 14 to be extended to next Wednesday, I'm okay with that. For this time, that's fine. So if you need that extra time for 13 and 14, I can extend it till a week from today, but the exam has to be due. So I can extend the homework a little bit, but you know, so reach out if that is your case, which you guys are pretty good about. Okay, so what's up with exam 2? Well, it's 21 questions, which honestly isn't too bad for 2 hours. That's not bad. It's going to cover section 7 through 12. You know, we just got done with that, so it should be fresh. It's not from something, you know, that you learned 2 months ago. It's something that's on your mind. You can use, it says scientific calculator. You can really use any calculator as long as it's a real calculator and not on your phone. You can't use your phone. I'm going to allow you to use the textbook. You can use any paper notes you want, and you will need to please do the best you can at numbering the problems, doing all your scratch work on a piece of paper so I can give you as much partial credit as possible. So please do it as orderly as possible, just like last time where you're going to submit that work, and then I can give you that partial credit on your exam. And so the exam is worth 20% of your grade. So it's really your time to shine and show me all the things you've learned. Okay. Oh, I should mention one thing it doesn't say there is that it doesn't say Excel. So you can't use Excel during the test. And that seems contradictory because you needed to use it for the homework and you needed to use it for the quizzes, but you can't use it for the exam. But the good thing is, since you can't use it for the exam, the questions are written in such a way you don't need to. So any information that you need from Excel is given to you. Most of the time, the Excel part is going to be interpreting, equals FV, some percentage divided by 12. You're going to be interpreting just like in the homework, right? You're going to interpret a function as it's written in Excel, or you're going to be given a scenario and you would choose, like a multiple choice problem, you would choose why does all this crazy stuff happen when I'm teaching? Of course, there's a guy walking on my porch right now. What was I on about? Oh yeah, so the questions are written so you don't need Excel. And that's good, actually. That makes it a lot easier. So using Excel wouldn't even help you, but it's a good thing because it's written in such a way where you don't even need it. So it's good. Yeah, so they'll give you a scenario. You'll pick out a multiple choice problem. They'll pick out which function you would need to use. If it's a future value problem, if it's a 401k problem, you're going to pick the FV function, right? Or maybe you have to pick out the FV function that correlates with that scenario. We even did some of that in class last time, where I gave you multiple choice, and everybody was doing awesome with that. So that's what the exam is going to look like. The next thing that I want to talk about is I made a list of topics. There's 21 questions. I made a list of topics that I think are worth going over. And then I just put them in this order. So 401k plans, hopefully that's fresh on your mind. If you're doing a savings account for 401k, we're just going to consider it a savings account, right? That was the FV function, the future value. Okay, so that's going to be on there. Absolute change. Remember absolute change, new minus old, or a value minus the reference value. That was absolute change. That's going to be that on there. APR to monthly rate. So annual percentage rate to monthly rate, right? We took the percentage, we divided it by 12. We've done that many times. That's what you want to do for the monthly rate. Compound interest. We did a lot of problems with compound interest. Is it compounding monthly, weekly, semi-annually, daily? So compound interest is on there. Credit card balance tables. Remember those questions where, we're given an initial value, we find the finance charge, we have the minimum payment, we pay the minimum payment, then we find the new balance. That you're going to see that on the exam again, right? That's going to be on there. It was on the homework, it's on the quiz. It's definitely going to be there. So there's a credit card balance problem. Down payment on a house. I wanted to just make sure that makes sense. When you're doing the mortgage, you're not borrowing the down payment. So sometimes it was like they put 20% down. So that means they're only borrowing 80% of it. They're not borrowing all of it. So you'll need to remember down payment on a house. The equation of the lines, y equals mx plus b, m is the slope, b is the y-intercept, the starting value. So you'll need to remember that. Exponential decay and growth, that had to do with percentage increase and decrease. And then how it's incrementing. Is it incrementing through a year, a week, a month, that kind of thing, which is very related to exponential. It's almost like compound interest. So we did a lot of problems with that. Finance charge. I'm sure you guys remember finance charge because you just finished it. Finance charge was you take the APR, you divide it by 12, and then you multiply it times the value. That was the finance charge. Future value, that's the same thing as a 401k plan, right? Savings account. Linear model with the given slope. So they're going to give you, a model slope. Can you find the equation? Can you find the linear model? So linear models to equation, y equals mx plus b, right? So I think that was section 8, maybe. The percent times base equals amount problems. We did a lot of problems like this. Find the base given a percentage and the amount, or find the amount given a percent and base. We did a lot of problems like that. Like the sales price was $16.99 and they got 20% off. What was the original value? We did a lot of original value problems. Or they got, they had a 30% off coupon and the original value was $30. What's the new price? So we did a lot of those, right? That's going to be on the test. Percent increase problems, percent decrease problems. That's very similar to what I was just talking about, but tax problems, if you're paying, this person is paying 20% tax or is taxed 20%, that's a percent increase. Or the amount of people riding the bus has gone up 20% this year, and it was 10%. What is it now? So we did a lot of those: percent increase, percent decrease. Relative change is actually another way of solving for percent increase. That was new minus old over old times 100 to find the percentage relative change. Slope of a line, the slope given two values. We did some of those where we subtract the y's, divide by subtracting the x's, subtracting the money over subtracting the time. Did a lot of problems like that. That's on there. And then lastly, looking at a graph and looking at the trend line, deciding, okay, is the actual value above or below the trend line? If you followed the model, would it be above or below? What does the model predict? So that's where we plugged it into the equation. These are the types of questions you're going to see. Okay. So that is essentially the test. I think there's like 19 things there. So that's pretty much what the test is. The test review should help you prepare. Definitely look over the homework again. But I think it's a pretty fair test, honestly. And you can have open notes, open book. So I think if you prepare, you shouldn't have any trouble. So I'll have office hours on Sunday night as usual if you want to come and study or whatever. And you can always email me and ask me questions if you have anything between now and then. But that is what's going on with exam 2. So any questions about exam 2? Okay, well, you can always let me know. But I think it will go well. I hope it will go well. So, and reading your discussion posts, it sounds like a lot of people have already been studying for it. So that's awesome. I think it's going to pay off. I want everyone to do super well. I want everyone to get an A. So, I think it's totally manageable. Okay, but let me know if you have any questions about the exam. Okay, so I want to talk about section 13. This homework will be due Tuesday night. If you need an extension, I can make it due Wednesday night. But this is 13. 13 is going to be converting units. So we're going to start talking about units like converting inches to miles, miles to inches, even get into like meters and kilometers, liters versus gallons. So units. This used to be earlier in the class, but they've changed the order in the past couple of years. So this is it's strange. Actually, I think this was like the first section before. So it's a different order, but that doesn't matter to you. So section 13 is now the units. And the good thing about the units is that all of there's a cheat sheet in the book. You can't really see it. It's like fuzzed out, but it's on page 235 in your textbook. You won't need it for tonight, but you will need it for the homework. And I will post a copy of it if you don't actually have a physical textbook, but it's page 235 and it's the yellow sheet. It's the yellow sheet. So it's in your textbook and it has all the conversions that you need for this class. So, we're actually going to use the textbook for once. So it defines a couple things, and one of them is an algorithm. And Okay, an algorithm is really just a step-by-step procedure. Okay, what does that mean? It just means that for us, it just means that we're going to come up with a systematic way of converting one unit to another. So, for instance, converting feet into inches is easy because there's 12 inches in a foot. So it just means we're going to multiply by 12. So that would be our algorithm there. The factor label method, really all it means is if we convert something from one unit to another, if it's dealing with a length, or let's talk about a fluid. So 2 liters of soda poured into a milk jug is the same amount of liquid, even if we refer to it as, an amount of gallons. Okay, well, it's just a fraction of a gallon. It's the same amount of liquid. And that's what the factor label method is saying, is that if you're changing the units, that doesn't actually change the quantity of the thing. Okay, so if I'm talking about something, it's half a foot long, well, that's 6 inches. Those are, half a foot of one, right? Half a dozen of another, that kind of thing. So that's all the factor label method means. Okay. I always start with this example, and the reason I start with this example is because you already know the conversions. So I'm going to convert 1 year into seconds. So you already know the conversions, so we don't have to worry about looking at the table. You already know how many minutes are in an hour, so we can just focus on the method. The method I'm going to teach you is the exact same method I learned, and it's the one displayed in the textbook. And this method it's really good for finding your way for multi-step processes that you don't know how to convert. But you probably already know how to do this one, so I just want to show you something that's approachable. So I'm going to show you how many seconds are in a year using the method we'll use in class. So I start with the 1 year that I'm given. I want to go from year to seconds. So I start with year, and then I just go with the next conversion I know, which is days. So there's 365 days in a year. So I'll go, okay, I'm starting with years. So I'll put years in the bottom, and I'm going to days. So there I have days over year. And now I'm in days. So I'll go days to hours. And now I'm in hours. I go hours to minutes. And now I'll go minutes to seconds. And there it is. So there is my algorithm. There is my step-by-step procedure of how I can get from 1 year to seconds. Okay. The units will cancel because I have years over years, days over days, hours over hours, minutes over minutes. The only thing that won't cancel is seconds. And so that's another way of showing that I've converted it to the unit I want, because I'm left with the seconds. They can't cancel anything. There's no other seconds, so they can't cancel. So it's another way of showing that I've converted to the right unit. So what does this really mean? It means that the answer will be 1, starting with the 1 year, 1 times 365 times 24 times 60 times 60. These are the numbers on top, okay? All the other numbers were just ones on the bottom. So 365 times 24 times 60 times 60, I get 31,536,000 seconds in exactly 1 year. So this is the method. This is the method of converting from one unit to another, creating this algorithm of conversion, okay? Now, it may seem silly, but this class at one time was developed for the nursing program. It was one of the main reasons that it was one of the main focuses for the class, and they do a lot of conversions in those classes. So they needed to have a major section for this. So That's kind of where this comes from. And the place that I saw it first was science classes that I took. And we had to do a lot of conversion. In my physics and chemistry class, we always have to convert stuff. So that's where I saw it first. But if you take any of those classes, maybe you've already taken them. Maybe you are. Maybe you do this for work. I don't know. But yeah, so we're just doing a lot of conversion stuff for a little bit. Okay. Let's look at more examples and make sure that it's easy stuff. Next thing I want to do is I want to convert 1 mile into inches. Well, this might be, we might be getting into stuff that you don't have memorized. Many of you may. So it's in the yellow sheet, page 235. If you want to follow along, but everything is in the slide. So I'm starting with miles. I'm going to go to inches. So I'm going to go from miles to feet. And there's 5,280 feet in a mile. Then feet to inches, 12 feet and 12 inches and 1 foot. So miles over miles cancels, feet over feet cancels. We're left with inches. That's what we wanted to go to. Mile to inches. Okay, so the answer is 1 times 5,280 times 12. So I got 63,360 inches. Okay. Okay, well, hopefully this is feeling easy, but are there any questions? Okay. Don't hesitate to stop me if you have any questions. So I'm going to go from gallons to fluid ounces. Again, these conversion factors are on that yellow sheet, and this is how I do it. So I start with a gallon because I want to go from gallon to fluid ounces. So I start with gallon, and then with our chart, I have to go to quarts. I go to gallon to quart, quart to pint, pint to cups, cups to fluid ounces. Okay. That's a lot of steps, right? But with our chart, that's the way we have to do it. And you can see that and it's at the top in the middle. It's the top middle chunk there. It has the little volume there. Okay, so that means that the units are going to cancel. We have gallons over gallons, quarts over quarts, pints over pints, cups over cups. So we're left with fluid ounces. The actual arithmetic is going to be 4 times 2 times 2 times 8. And that'd be 128 fluid ounces. You go, well, I could have just Googled that. That's easy. I don't have to do all that step. If I just Google it, Google has a converter, which is absolutely true. But I'm not, just in case that's going through your mind, which I would understand if it was. The thing I want to say is I'm not teaching you how many fluid ounces are in a gallon. So that's not what I'm teaching you, because that's pointless. There's no reason to memorize that unless you need it. That would be useless information. What I'm trying to teach you is the method of converting something, or being able to take something, a big conversion, and break it up into chunks that you can do. That's what I'm trying to explain. So just in case there's any confusion, that I'm trying to explain how many fluid ounces are in a gallon. I'm not, that you could just look that up. What I'm trying to teach you is the method. So that's starting with easier problems and explaining the method of how we can convert things. Okay, hopefully that's clear.
I do have one question about that.
Yes.
If we have something like that on the final exam, and we know part of the other part, can we simplify that? Like, say it gives us, you have 3,000 gallons, how many ounces do you have?
Mhm.
instead of 1 gallon. Can we combine some of those steps?
Yes, you can. Mhm. The thing
Thanks.
I would be, the thing I would just be careful with, um, so we're going to see where I would be careful. So what we just went over, I think would be fine. If you want to skip a couple steps, you're good. Until you start getting wrong answers, then you know you'd have to go back. But when we start converting from the metric system to the imperial system, which is what we're about to talk about, that's where you can run into problems, because then you can start running into like serious rounding issues if you
Yeah, I wouldn't
skip
try it
it.
on that one.
Okay, I'm just saying, yeah,
Mm.
it's a perfectly valid question, because my fear is that uh, you as the student, anyone that's listening, you as the student are going to think that we're going over this to learn how to bake or something, which would be awesome if that helped you in your baking classes. And I know for a fact, one of my good friends, who is an awesome mathematician, went into culinary and used to teach all the culinary people how to convert. If you're one of those people and this helps you, that's awesome. That's not actually what I'm teaching. I'm trying to teach how to break up big problems into smaller chunks that you can manage. That's what I want to teach. Um, I know that you can look this up in Google, and I know you can convert it, and I think that's awesome. And for the most part, in my everyday life, I would too. But um, the point is to get the practice of breaking this up. Okay, so when we convert from the metric system, which we haven't introduced it yet, but when we convert from the metric system to the imperial or back and forth, that's when we can really run into problems with rounding. In fact, it's happened a lot. In fact, NASA lost a, a sizable project, millions of dollars, because of a conversion error. They sent some probe to Mars like 10 years ago, and there was a conversion error in their arithmetic, and for some reason, no one caught it, and it just burnt up. And it's unbelievable that actually happened, but it really did. No one checked the units, and that's a real thing. Now, I'm not saying you're going to work at NASA or whatever, but obviously errors can happen. Errors happen, right? Okay, so the metric system. This could be the first introduction you have to the metric system. If you take any science classes, if you take nursing classes, you're probably going to have to deal with it a lot. We deal with it a little bit in our everyday life. Like liters, you can buy, like we buy 2 liters of soda or 2 liters of drinks for whatever reason, and I have no idea what the reason is. Maybe you do, but for some reason we use 2 liters for soda, a gallon of milk, which is a whole nother, like, you know, we kind of mix it up. So a liter has to do with an amount of liquid, a volume. A meter has to do with a length. So a meter is kind of like a yard. If you ever dealt with a yardstick, if you know what a yardstick is, that's pretty much a meter. That's pretty close. And we'll get into centimeters, which are similar to inches. Weight, the weight of something, how much something weighs, that's usually done in kilograms or grams, depending on the accuracy you need. These days, when I go to the doctor's office or I take my son to the doctor, I don't know what your experience is, but they actually do the conversion on the scale, but they seem to weigh people now in the metric system, and then the machine just converts it. And I think that's because it can be more accurate. In fact, if anyone's super nerdy and interested, the pound is actually defined now in metric systems, and then they just convert it. So I think that's kind of funny, but the definition of a pound is now a certain amount of grams, which is kind of interesting. So anyway, the metric system. So the metric system is just a system of moving decimal places, which is kind of nice. So when you're in the metric system, if you want to go from a single unit to a kilogram, you can just move the decimal place. Once you're in the system, you can just move it. So kilo just means 1,000. So something that weighs a gram is extremely light. Kilograms kind of like a pound. That would be a good comparison. But you can just move the decimal places, and that kind of helps. I'm also thinking some of you may not have even grown up in the United States. So some of you may have experiences in Canada or Europe or wherever, and they often use the metric system there. The US is one of the few that still uses a different system. Centigram, centimeter, that just means 1 out of 100, just like our cents do. So there's 100 cents in a dollar. There's 100 centimeters in a meter. There's 100 years in a century. There's 100 centigrams in a gram. Okay. Centi means 100. And then milli means 1/1000th. And it sure would be nice if milli meant 1/1,000,000th, but it doesn't. So, a missed opportunity there, but it's 1/1000th. So that's the milli. Okay. 3 zeros. So there you go. So I'm going to practice my metric system, assuming that you haven't done that before. So if I have 1 kilometer, I'm going to go, 1 kilometer to millimeter. Okay. So I start with my kilometer, and I'm going to convert that to the base unit. Whenever I'm in the metric system, I always like to convert it to the base unit and then go to wherever I'm headed towards. So for kilometer to meter, kilometer, the K stands for 1,000. If you make 100, that car costs 100K. The K stands for 1,000, right? So 1 kilometer to meter is 1,000. And then I'm going to go from meter to millimeter, which is also 1,000. There's 1,000 millimeters in 1 meter. So it's 1,000 times 1,000. And there's my million. So there's 1,000,000 millimeters in a kilometer. So there's my milli. Okay. But you can also see I just moved the decimal place, right? I just moved the decimal place 6 spots. So when you're in the metric system, it's actually extremely easy. Okay. Convert 1 liter to milliliter. It's going to be very similar. Liter to milliliter. Milli is 1/1000. So there's 1,000 milliliters in 1 liter. Liters cancel. 1 times 1,000. It's just 1,000 milliliters. Okay. I just moved the decimal place. That's all I did. Convert 1 gram to kilograms. Well, you might already know the answer. 1 gram to kilograms. Cancel the grams. 1 over 1,000. It's 1/1000th of a kilogram. Okay. Pretty easy. Just move the decimal place. The difficulty starts when we try to go back and forth. When we try to go back and forth between the two systems, that's when we get a headache. That's when it starts. So I put a little joke here. US in the metric system, a pain in the foot. So this is the same thing on the yellow sheet where it has the conversion factors between the systems. So this is the ones you want to use. This is what I was talking about with Carol. This is the one you want to use when you're converting back and forth between the two systems, okay? Because this is where we're going to get those rounding errors. So if you're converting a length, you want to use these conversion factors. So inch to centimeters, centimeters to inch. Now, 2.54 centimeters is exactly 1 inch. We don't worry too much about error in this class. If you become an engineer, you'll worry about it every day. But it is exact. So it's always a really good conversion factor to use if you're really doing real life conversions. And when I was in school, they always kind of have this focus on using that one because it was exact, and so you wouldn't introduce any errors. But we also have 1 yard equals 0.9144 meters. So you can see that a meter is just a little bit shorter than a yard. But that'll give you a sense if you've never seen a meter stick. It's basically a yardstick, and hopefully you've seen those in your life. 1 mile is 1.6 kilometers, so kilometers are a bit shorter than a mile. Volume, we have a quart to liter reference there. A liter is just a little bit less than a quart. And then pound to kilogram. Kilogram is a little bit less than half of a pound. And an ounce to grams. Okay. So those are the conversion factors that you'll see in the yellow sheet in the book. Please use those for your homework. And it's technically already uploaded in the textbook solutions. You will see a copy of that. If you don't have the physical textbook, it is there. So, okay. So all listed on the yellow sheet. But let's try to convert here. So convert 1,000 kilometers to miles. So this is the conversion between the two systems. So 1,000 kilometers to miles, I'll use the very same conversion factor that I showed earlier. Kilometers cancels, it just means I divide. So I got roughly 621.4 miles. Okay, it's approximate. I'm just rounding tonight just to show you the idea, okay, to use that conversion factor. But please use the conversion factor in the book when switching between the systems. Now I want to go the other way. What about 1,000 miles to kilometers? What's the difference? So the previous slide, I did kilometers to miles. Now I'll do miles to kilometers. What will be the difference? Conversion factor will go on top, okay? If I'm in miles, miles will go on the bottom, kilometers will be on top. Okay, units cancels predicted, just multiply it. You can see, just move the decimal place. If it was anything other than a 1, it would be a little different, but just multiply. Just multiply in the top. In the previous example, I had to divide. Okay. Now, we also have to talk about temperature. So the two systems have a different way of measuring temperature. There's Fahrenheit and there's Celsius. So Fahrenheit is usually the one we use in America. What is it? It's like 50. I don't know where you guys are, but where I'm at, it's like 55 degrees. It's kind of chilly today. So it's like 55 degrees Fahrenheit. So that would probably be something in the teens Celsius. So there's the two systems. Now, I'm not going to bore you too much with the systems, but the Fahrenheit system, when they were developing the temperature scales, the Fahrenheit was based on the temperature outside. That's the way I understand it. It was developed with the idea of what is the temperature outside, and 100, I heard, was the hottest it had ever been in the village that the person that developed it. That's the story I read. I think it was like Danzig, Germany. This person is the hottest recorded. So he had these measurements, and that was the hottest spot. So that must be 100. Now, body temperature 98.6 on average. That's what they always say, though I read that it's going to go down. 32 degrees Fahrenheit for freezing water, and 212 for boiling water. Now, the Celsius scale is defined much more simply in terms, especially in the lab. It's 100 degrees for boiling water. So it's all based on water. So 100 degrees for boiling water, 0 degrees for freezing water. And then they just made 100 notches in between. So that actually means it has less accuracy. So generally with Celsius, they will do decimal places. And with Fahrenheit, there'll be less because there's a difference of 180 degrees in the Fahrenheit, and there's only 100 in the Celsius. But Celsius is based off of water. Fahrenheit is basically based off of, it's all confusing. They're all based off of temperature, but the Fahrenheit is based off of the temperature of like our everyday outside life. Okay. If you go into science classes, they have yet another temperature scale, which is, kind of a scientific one. It's called the Kelvin scale, and it's based off of the theoretical idea that there is a 0 degree temperature, that something could be so cold that even the molecules, the atoms, the particles, the electrons inside a substance would stop. There would be no energy, and that would be 0. We don't get too much into that. If you go into chemistry class, they'll probably bring it up. Maybe biology class, they bring it up. I don't know. Those are taking biology. So there is that scale out there, the Kelvin scale. But we're going to talk about Fahrenheit and Celsius. Okay. So here are the two formulas. They're listed on the yellow sheet, kind of in the center here. So they're right there, same exact ones. Fahrenheit, Celsius 2 Fahrenheit, Fahrenheit 2 Celsius. They have the 9/5 and the 5/9. You can see. For the Celsius to Fahrenheit, we take the degrees in Celsius, multiply it by 9, divide it by 5, add 32. There's your Fahrenheit. But from Fahrenheit to Celsius, we take the Fahrenheit, subtract 32, then multiply by 5, then divide by 9. That's how we calculate it. So those are your two formulas. What is the significance of 32? That's the Fahrenheit freezing water. So that's where that 32 is coming from. Okay. Okay. So let's try a couple of examples. Let's convert 32 degrees Fahrenheit to Celsius. So we're starting with Fahrenheit. We're going to Celsius. So I'm going to use this formula, which helps me with Fahrenheit to Celsius. Celsius is on the equal sign by itself. That's how I know to use that formula. So I'm going to plug in the degrees Fahrenheit into the formula. It will output the degrees in Celsius. So I plugged in 32. Well, I'm going to have 32 degrees minus 32 and 0 degrees Celsius. Okay. Let's convert 98.6 degrees Fahrenheit to Celsius. So this would be average body temperature. So I'm going to go from Fahrenheit to Celsius. Plug in my value, 98.6, subtract 32, 66.6, multiply that by 5, divide by 9. I get 37 degrees Celsius. So that's average body temperature is 37 degrees Celsius. Okay. Any questions about temperature? Any questions at all? I hope it's easy. You just plug in the value, calculate it, convert it. Okay. There shouldn't be any error for that one. That shouldn't be a big deal. Okay. No questions. I'm going to go to 14. With 14, the book is going to start bringing up certain applications of these conversions. And I don't know what people's backgrounds are. So I'm going to go over a certain amount of things that you might need. You might not have any background, or you haven't seen it for 25 years. I don't know. I don't know what people's backgrounds are. So I wanted to kind of help you out with that. And so we're going to mention some rectangles, some box shapes, cubes, circles. I don't know what people's background is. So I want to go over it just a little bit, just to make sure that everyone's on the same page. So if we want to find the area of a rectangle, we have length and width. And to find the area that's shaded in region, that would be area equals length times width. That would be the area. So you can do that with a square. You can do that with a rectangle, length times width. Okay. Now, a box shape is very similar, except it's a three-dimensional object. And so it would also be length times width, but it will have a height. It has that third dimension. And since it's three-dimensional, it has a volume. Okay. Area for 2D, piece of paper, flat surface is area. Volume is three-dimensional. Okay. I'm sorry if you are rolling your eyes, you already know this, but I just want to make sure everybody's on the same page with that. So area of a circle. With a circle, we need something called the radius. That's the distance from the center to the out, and it'll be the same if it's a perfect circle. And so to find that, we have to use this weird, funny number called pi. And then we use that radius and we multiply it times itself. So we go radius times this weird number called pi. And pi is a ratio that has to do with every perfect circle there is. And if you want, you can just use 3.14. Your calculator probably has a pi button. Most calculators do. And it'll have all kinds of digits associated with that. But you can use 3.14. That's good enough for what we do. Or you can use the pi button on your calculator. But the r is squared, which means it's multiplied times itself. So the radius times that 3.14, that is the area of a circle. Okay. And then a cylinder is like a three-dimensional object, kind of like this box. And it has the circle on two sides. So it has a radius. It's just like this box, except instead of a rectangle, it has a circle. It has the height associated with it. So of course it's going to be that area times the height, just like the box was. So pi r squared times height would be r. Yeah, that would be our volume of a cylinder. Okay. So you'll have to use those formulas, and we don't have to go any further in depth with that. Luckily, we're going to use simple shapes. We're not going to do anything too complicated, but there'll be a few problems where we have to use those. Let's do a word example. So Drew is planting some grass, and the lawn is a rectangle, and it measures 120 feet by 75 feet. Drew uses 1 pound of grass seed for every 200 square feet. How much grass seed does Drew use? Okay, well, let's pick this apart. So I'm told that this is a rectangle. So, okay, this guy just mentioned something about rectangles. So that's probably what we're going to use. I have 120 feet by 75 feet. So that would probably tell me the area. Then there's some conversion. We use 1 pound of grass for every 200 square feet. So how does that connect? Well, we can convert the area of this this garden into pounds of grass seed. So the first thing I'm going to do is I'm going to find the area of the garden here. So I have length times width. That's the area. So 120 feet times 75 feet. That gives me 9,000 feet squared. The units also are multiplied. Feet times feet is feet squared. And that's what square feet are. The grass seed is for every 200 square feet. So that's that foot squared. So I can convert that now. So I have 9,000 feet squared. That's Drew's garden divided by the 200 feet squared. That's how many pounds of grass seed. And that would give me 45. So that'd be 45 pounds. Okay. So we have to do a little bit of simple geometry to continue with our conversions, but it's nothing too wild. Most of you probably already know that, but hopefully that will get you going in the right step with that. Okay, calculate the volume of a box with dimensions 3 feet by 4 feet by 36 inches. Well, we were just talking about the volume of a box earlier, so that seems kind of simple. It was just length times width times height. The only annoying part of this question is that they're not all in the same units. And that is something they definitely like to tease us with. We have feet by inches. And if we're going to calculate the volume, we have to be in the same unit. So that's kind of annoying. So we have 3 feet, 36 inches. But if I converted those 36 inches into feet, then I could find the volume of the box in feet cubed. Okay. So that's what I'm going to do. 36 inches into feet. Well, I'll just divide by 12. So that's 3 feet. So then I switched there. So now I have 3 feet by 4 feet by 3 feet. Now they're all in the same unit. Awesome. Now I'll find the volume. The volume is length times width times height. So 3 times 4 times 3, 9 times 12. Wait, what did I say? 9 times 12? Yeah. Any questions about that? Nine times 4. Don't know why I said that. And then I want to mention that the feet has a little 3 on it. That means that it multiplied times itself 3 times. That's a volume. The cube is a volume. Cubes are volumes. Squares are 2-dimensional, flat. And then 1 is just 1-dimensional. Okay. All right, calculate the volume of a cylinder in cubic inches with a radius of 2.9 centimeters and a height of 0.35 yards. So this is a really silly question because they want it in cubic inches and they gave us the measurements in centimeters and yards. So they couldn't be more aggravating. in this problem, but we can convert and solve. Okay. So it's a cylinder, so I'll use my cylinder. Now the radius was 2.9 inches. The height was 0.35 yards. So I need to use my cylinder equation. So there's my radius, there's my height. But I'm going to need to convert these into inches, otherwise this isn't going to make sense. So that's what I did in this step. I have 0.35 yards. I'm going to inches. I need to convert the 2.9 centimeters into inches because it asked for cubic inches. That's what the question asked for, but it didn't give me anything in inches. So I had to convert. There I have converted it. I can plug it in my formula. And there's my answer. Okay. So that is the method. Of course, it's, it's math class, so it's got to be silly. They got to give you the question in the wrong units that they want the answer in. So sometimes you have to convert before you even plug it in. Okay. So section 14 is going to cover a lot of applications such as area, volume, dosage, right? This was a nursing thing before. And even CO2. CO2 is carbon dioxide. Carbon dioxide comes from like cars. We breathe out carbon dioxide, so there's some carbon dioxide problems. And another thing I want to mention is that the M with the 3 on it, the feet with the 3 on it, inches with the 3 on it, that indicates that it's cubed. And we have to, if you wanted to convert something that was cubed, you would have to do it 3 times. And I think I have an example here that shows that. So we want to convert 3,200 square centimeters to square inches. Okay, so now we're doing 2-dimensional objects with conversions. And since they're square, which means 2, we have to do the conversion twice. We have to do it twice, not just 1 time. So I start with my 3,200 square centimeters. I convert it twice. Okay, it's squared, so I have to convert it twice. Right? You can think of it as centimeters times centimeters. So I have to convert it twice for it to work out. So I get 3,200 divided by 6.4516. That's, if you multiply these two numbers together, roughly 496 inches squared. So if you want to convert something like that, or if you're asked to, if it's squared, you have to do the conversion twice. If it's cubed, you have to do the conversion 3 times. Okay, dosage. Dosage calculations, I think, are probably the most confusing, complicated part of this whole section. Okay, well, it was originally developed to help nursing students with the math that they need to do. So this is something that they go through. Though every nursing student I've ever talked to said they don't actually convert, a machine converts it for them, but we'll see what goes into it. Okay. So these would be the more challenging ones, I think. All right. The dosage for a certain drug calls for 15 milligrams per kilogram per day and is divided into 2 doses. 1 dose is for every 12 hours. If a person weighs 160 pounds, how much of the drug should he or she get for each dose? Okay. So believe it or not, you may already know this. I don't know what you guys already know, but a lot of drugs are labeled like this: milligrams per kilogram of the patient. So even drugs that are manufactured in the U.S., sold in the U.S., prescribed in the U.S., they are prescribed or given out in milligrams per kilogram of the patient. So whatever you weigh is going to be judging on how much of the dosage it should be. Okay, and then also there'll be a certain amount of dosage per day or split out throughout time. Okay, so this patient in this problem weighs 160 pounds. Okay, another patient might weigh 300 pounds. Another patient might be a child, only weigh 30 pounds. So they would need different amounts of these drugs. So we need to figure out a way to systematically convert the proportional amount of medicine for their weight. Okay. So I would always start, if you want to make this note, I think it's worth writing down, always start with the patient's weight, because that's the variable. That's the thing that changes each problem. Don't start with the drug conversion. Start with the patient's weight. This patient weighs 160 pounds. So I would start with 160 pounds, and then I would convert from there. Okay. So we need to convert from pounds to kilograms starting off, and then we can figure out how many doses this patient would need, or how strong those doses would need to be. Okay. So what I'm looking for is a way of going from pounds to milligrams. All right. I know the patient weighs 160 pounds. I know it's 15 milligrams per kilogram per day. And I know we're doing 2 doses a day. Okay. So I'm going to find how many milligrams will be in each dose. So I'm starting with the patient's weight. That's what you should do. Start with the patient's weight and then work your way from there. So we're starting with pounds. Next thing to do would be convert that to kilograms. So that's what I did there. I used the conversion factor that's in the yellow sheet. Then I'm going with the medicine conversion, kilograms to milligrams. That's something that has to do with the medicine. That's not on the yellow sheet. It has to do with this particular medicine. Okay, kilograms to milligrams. This one is per day, right? So they get 15 milligrams for every kilogram they weigh for a day. But we're going to do 2 doses in a day. So I need to divide that by 2. 1 day, 2 doses per day. So I need to divide that by 2. So I got roughly 544 milligrams for each dose for this patient. Okay. Always start with the patient's weight. And they're going to be given to you in pounds because that would be the most annoying way to give it to you. So that's the way they give it to you. So that you're going pounds to kilograms, then look for whatever the dosage amount is. It's either going to be kilograms to milligrams or kilograms to milliliters. We'll see that later. It's just the way that medicine's given. And then however many doses they're given throughout the day. I think one of them we're going to go over, there's 3 doses. There's 3 doses a day. This one was 2. Okay, let's go over another one. If a drug has a concentration of 550 milligrams per 10 milliliters, how many milliliters are needed to give a 10 grams of the drug? Okay, this one doesn't give the patient's weight. This is a concentration thing. We have 550 milligrams per 10 milliliter. How many milliliters are needed to give 10 grams of the drug? So what do we start with? I'm going to go grams to milliliters. That's what the question's asking. Go to grams to milliliters. Start with 10 grams. Go to milligrams. That's the way that the concentration is given. It's given in milligrams. Milligrams to milliliters. And there. I don't remember why I chose to round it that way, but that's how you would convert it. Grams to milliliters. That's what the question's asking. It's asking, start with 10 grams. How many milliliters are we giving? If it's 550 milligrams per 10 milliliter, and you got 10 grams, how many milliliters? That's what we're doing. So it's really just asking grams to milliliters. Okay. Next one. Doctor orders 4.5 milligrams per kilogram of a drug for a child that weighs 88 pounds. The drug is available at 125 milligrams per 3 milliliters. How many milliliters must you administer? So what is this question really asking? It's asking convert pounds to milliliters. That's what we want to know. We want to know if the kid weighs 88 pounds, how many milliliters are we giving them? That's what we need to know. So start with the patient's weight and go forward. We're starting with pounds. Of course, the medicine is always labeled in kilograms, so we have to convert to kilograms. I use my yellow sheet to do that. Kilograms to milligrams, that's to do with the medicine, okay? That's not a metric thing, that has to do with this medicine. This particular medicine is 4.5 milligrams per kilogram for every kilogram the patient weighs, okay? Then we go milligrams to milliliters because that's how it's available. So it's 125 milligrams for 3 milliliters. Now we can find how many milliliters are we supposed to give? 4.31 milliliters. Okay. So the question was really asking, convert the patient's weight to milliliters of medicine. That's what we found. Okay. I think they're the most confusing, but I'm trying to break them down in such a way, hopefully it feels a little simpler than just staring at it. So ask yourself, what am I converting to? I'm given the patient's weight. What am I trying to get to? Am I trying to get to milligrams? Am I trying to get to milliliters? How can I do that? Okay, let's do another one. So what is the milliliter dosage given to a man that weighs 202 pounds if the doctor orders a daily dosage of 5 milligrams per kilogram and the drug only comes as a fluid where 5 milligrams is equivalent to 9 milliliters and it's administered every 8 hours? Okay. Well, I know what the patient's weight is. It's 202 pounds. The doctor's saying we need 5 milligrams per kilogram, but the medicine only comes in 5 milligrams per 9 milliliter. So what are we trying to get to? We know where we're going to start. We're going to start with the patient's weight. And then we're going to give this patient a dosage every 8 hours, but we have a daily dosage of 5 milligrams per kilogram. So we also need to figure out how many doses is this patient going to get. Well, I would say they're going to get 3 because it's every 8 hours. But let's try to get into it. So we got 8 pounds, or we got pounds to milliliters. 202 pounds. We're trying to figure out how many milliliters are we giving this patient per dose. So start with the pounds and go to kilograms. Now this is the doctor's orders. Doctor ordered 5 milligrams for every kilogram. Then the drug comes 9 milliliters per 5 milligrams. That's how the drug comes. So we have to do that. And then it's 3 doses a day, 8 hours for 24, or just 3 times. So I got 274, roughly 275 milliliters. Obviously, I wouldn't be so lackadaisical if I was really a doctor or a nurse administering medicine, but for our purposes, it's roughly 275 milliliters for this patient, for each dose. Okay. So always start with the patient's weight because that's the variable. All right, the last topic is CO2. So CO2, when we used to do 3 projects, in this class. And the third project had to do with CO2. So you would figure out, okay, I drive this far to work. I have all these TVs in my house. I have a refrigerator that runs all the time. How much CO2 am I producing a year? So that was the third project, but we don't do it anymore. But we still have practice with the homework. So the two conversion factors you have to know for CO2 is pounds of CO2 per gallon of gasoline that's consumed. So it's roughly 20 pounds of CO2 per 1 gallon of gasoline. And then it's 1.37 pounds of CO2 per kilowatt hour of electricity. So burning electricity, you're still going to produce CO2, and it's 1.37 pounds per kilowatt hour. Kilowatt hour is what the power company measures electricity energy. So kilowatt hours. So we're going to do some examples with that. Okay. How many pounds of CO2 are made from driving a car with 32 miles per gallon? You drive a total of 870 miles, I guess, for a trip. So start with the amount of miles for the trip. So we have 870 for this trip. We're going to start with the 870, and we're going to get to pounds of CO2. So start with 870. This car is 32 miles per gallon. So I go miles over miles to the gallon. Then I use that conversion factor that's given in the book, gallon to pounds of CO2. And now I can convert how many miles to pounds of CO2. So I got roughly 538 pounds of CO2. CO2 is a gas, so it's kind of confusing to think of a weight for a gas, but it is how it's weighed. So this would be pounds of CO2 that's produced. How many pounds of CO2 are made from a computer monitor that's 80 watts that's being used for 32 hours in a week? This is something, I could do better at myself. I often have my TV on the wall, it's not even on, it's on the wallpaper. I'm too lazy to turn it off. I got my computer monitor on all the time. So this is something I could do better with. But this particular computer monitor is 80 watts. So how can we figure out how much CO2 is produced with it being on for 32 hours a week? Mine's probably on a bit more than 32 hours. So 32 hours times the watt, that's watt hours. Then we convert the watts to kilowatts. Remember, kilo means 1,000. So I just convert it to 1,000. And then the conversion factor in the book, 1.37 pounds of CO2 per kilowatt hour. This gives me approximately 3.5 pounds of CO2 produced by just a computer monitor every week. Okay. So what's due? Test review and exam 2 is due by Sunday midnight. You got 2 hours to take it. I didn't make it longer, just gave you more time to take it. Okay. So you could still come to office hours if you're a night owl. I know some of you are. If you're a night owl, you could come to office hours and still have time to take it. And then Tuesday night, you have homework sections 13, 14, and discussion 6. If you need an extension for homework 13 and 14, it's fine with me. I can make it due Wednesday, but you still got to turn in a discussion section. I can't extend that. Okay. Let me know if you need an extension for 13 and 14. Still got to turn in a discussion. Yeah, so that's what's due. Obviously, the most important thing right now is the exam. All right, so definitely study for that. A couple other things, unless there's any questions, there's a couple other things I want to talk about. Not like new subjects, but just to get everything clear. But are there any questions? Now would be a good time for questions. Okay. couple things I wanted to show you. Okay. We already talked about the test. So the test review, in case you didn't catch it, there's a couple questions on the test review. I don't want to show that part. Can I take it again? Yeah, you can take it unlimited times. There's some pictures for the test review. Make sure those are showing up for you. You get unlimited attempts on the test review, but I'm just scared that these pictures aren't going to show up. Ooh, look, one's not showing up now. Question 9. That's interesting. Why it's doing that? That's what scares me. Okay, I'll look at that after class. I
Could you,
re-uploaded. Go ahead.
could you just upload them on a separate file in the thing and we could just pull that off and print it off and say this picture
Sure.
goes with number 9, and this one goes with number 6, and that way we'd be sure to have it when we open the test review?
Yeah, it doesn't. I was hoping you wouldn't even have to do it. I was hoping it would just. I'll look at it again. I'm gonna try to get it right. It's possible I did that one wrong, but I'll try to get it right. But also I'll do that. I could. I think the easiest way, because I don't want it to get too confusing, so I could upload it to a image sharing site. You could click on it if it's not displaying, and it would just take you to a link. That way you wouldn't have to shuffle everything. I'll get it working. It looks like there's only one that's not working. I apologize. I noticed it wasn't working, and then yeah, it's just okay. Number 9, but the test is definitely working, so that's good. That's good. Okay, I will look at that right after class and see what's going on. Oh, the other thing that I wanted to talk about was the homework. Let's go back to modules. Sorry for all the flipping. Okay, test review, academic honest policy, the actual exam, and then you're going to upload your partial credit. So please do that. Please do that so I can give you as many points as possible. Here is section 13, broken up into 2 pieces. Section 14, the textbook solutions are already posted for you. So hopefully that helps. Let's flip through the homework, make sure it makes sense. So you're going to convert miles to feet, round to 1 decimal place, tons to ounces. We didn't do any tons in class. Conversion factors on the yellow sheet. Seconds to days, we did do gallons. So, I think it's pretty straightforward. Cups to gallons. Yeah, it's not too bad. It's not too bad. The only thing that could be a little annoying is those dosage. So, definitely watch those videos, go over the textbook for those, make sure that you understand that material. But in section 14, we have the wattage, the CO2. Those can be a little confusing. Carbon dioxide. Here's, you see where they're converting with the squares, miles squared, feet squared. That's where you have to convert it twice, like we talked about. Area of a circle. Volume, centimeters cube, feet cube. So you have to convert it twice. You have to go to centimeters, to inches, to feet. You have to do it 3 times. Volume of a box. Feet, inches. This is just like the one we did in class, except they give it to you as 3.4. So watch out for that. Yeah, here's the drug concentration. Milligrams per milliliter gram of a drug. So look out for that. We did one in class. Go over that again. This one's just like the one we did in class. Patient weighs 283 pounds. Start with that. Patient weighs 159 pounds. So always start with the patient's weight. That's the variable. Okay. So that's the homework. And then in case that's not enough to do, I know some of you are working ahead. Project two is open. So I opened it up. If you want to begin it, you can. This is the financial project. And in this project, you are going to compare an individual with your dream job compared to a person that only graduated high school with their given income. So in the project, it gives you an income of the average salary of someone that only graduated with high school versus someone with your dream job. And then you can compare the two. We're going to go over this in class next time, but it's open if you want to work on it. Next time, I'm going to show a worked example. So everyone's going to have different work next time because everyone's probably going into different, I mean, not necessarily. Some people might be going into the same career, but often a lot of people will be going to different careers. So I will show a worked Excel example of that next time. Right now, I think we probably have enough to work on, but in case you don't and you want to keep working ahead, it is open for you to look at. Okay. Yeah. So next important thing is the exam. That's due Sunday. I'll have office hours. And then if we want, we can have office hours on Tuesday night to help with the homework. I'm okay with that as well. I know not everyone can make all these office hours, but the best I can do is offer. So if we want, we can have an office hour Tuesday night, like we've done in at least one before. Otherwise, just let me know. Email me, message me, and I'll get back to you as soon as I possibly can. And which will probably be quick because I have a lot of stuff to do of my own work, so I have a feeling I'll be chained to the desk a lot this weekend. So I'll probably be reachable. Yeah. So that's it. I'll stick around for questions, but that's the plan. That's what's due, and that's what you need to learn.